Good afternoon. Thanks everyone for joining us today for the webinar. For our webinar, our topic is why do DataOps? My name is Beth Pfefferly. I'm the VP of Marketing at Data Kitchen, and I'll be the host today. We're happy to have you all here with us. Hopefully this webinar will be a nice distraction from everything that's going on in the world today. So before we get started, I'd like to just start with a few housekeeping items. The webinar is being recorded, and we will send a recording to all participants after the webinar. You're also all on mute, so we'll use the last 15 minutes of the webinar to answer questions. During the webinar, please enter your questions into the questions box on the webinar control panel. We'll collect them all during the webinar and answer them in the Q&A session at the end. Next, I'd like to introduce our speaker. He is no stranger to many of you who closely follow DataOps. Chris Bergh is the founder, CEO, and head chef at Data Kitchen. He's a leader in the DataOps movement and has more than 25 years of research, software engineering, data analytics, and executive management experience. At various points in his career, he's been a COO, CTO, VP, and Director of Engineering. Through these experiences, Chris realized that there had to be a better way to quickly deliver innovative analytics without errors, which led to the founding of Data Kitchen. He's the co-author of the DataOps Cookbook and the DataOps Manifesto, and a regular speaker on DataOps at many industry conferences. So with that, I will hand it over to Chris.
So thank you, Beth. And there's a question about whether people could hear. So hopefully people can hear. I'm just going to ask, can you all hear us? So I'm going to go on the assumption that you can hear us and keep going. So Beth,
yes,
that's a good idea. Just keep going.
So, yeah,
okay.
and we got some affirmation that they could hear.
Okay, so I moved to the second slide, and so we have sort of a jam-packed agenda today, and you know, the purpose is to kind of talk about the why of DataOps and less about the how or the who or even the when of DataOps. So why do it? Why bother at all? And so we're going to talk about, at the beginning, we're going to talk about sort of three concepts, and really there's sort of a failure that's rooted in people and process. And we're going to talk about why that process problem exists, why that people problem exists, and then we're going to talk about how the concept of DataOps fixes it. And then, of course, we're going to talk a little bit about how Data Kitchen can help, and then have some questions and answers at the end. And again, like I said, you know, there's just a lot happening in the world. The world has changed so much in the last 2 weeks, and you know, my biggest challenge is, as you can see in the webcam, is working from home. But there's a lot more people with a lot more worse situations, so our hearts go out to them. So that being said, I want to start off our discussion sort of a very big, and again, almost a negative way of speaking, although I don't mean it negative, is that I've been in the data and analytics industry for many years and have actually done a bunch of different roles as a data engineer or a data scientist, and manage people who are speaking in teams. And all heard about the cool data and analytics, whether or data science or data lakes or machine learning or AI. And one of the challenges is that these projects themselves are not really being successful. You know, 60 or 80% of analytic projects fails, according to Gartner. 87% of data science projects never get into production. Some companies who are calling themselves data-driven, which is sort of the highest point on the scale, are going down. And you know, we did some surveys actually last year, just to kind of validate that we're not crazy. And you know, we just asked the question, how many errors do you have? And we're going to talk a little bit about this. And the errors could be that the data quality is bad, or something happened in the processing of the data, or you know, the server went, or you're late. And we just found out companies have a lot of errors per month. And you know, I think there are just way too many errors. And then we asked another set of questions about how fast can you deploy, that is, take the stuff that you've done in your development group. Maybe it's a new model, maybe it's a ETL program, maybe it's a new visualization, and get it into production. And most companies are actually very slow in deploying changes from development to production. And so we actually wrote a white paper on this that has more detail, but it sort of, I think this is something that you can agree with, that there's just some challenges in data and analytics. And I grew up in Wisconsin in the 70s and 80s, and I actually saw the auto industry in Wisconsin suffer at the feet of the Japanese manufacturer. And I look at the analytics industry sort of kind of like the US auto industry in the early 70s. We're producing cars that just have a lot of defects. If you see the picture in the bottom, we're not on rapidly addressing customer requests, and it's very slow cycle time. And you read about what happened in the assembly lines of Detroit in the 70s, that morales are down. And so another way to look at it is that, and I've managed teams of data scientists and data engineers, and our prospects have validated this as well, is that the time that your team spends overall is not what you think. You'd hope that they would be doing really good stuff and doing new features, new analysis for your customers, and integrating new data sets. But there's a lot of time spent on sort of errors and operational tasks. And that comes from a lot of reasons, and I think it comes from complexity. And there's a lot of complexity in how teams are organized and their roles. There's a lot of complexity in their tool chains. That is the tools that each individual uses, their ETL or data science or biz tool. There's a lot of complexity in data, its size, and there's a lot of complexity in integration across all these teams and locations and clouds and data centers. And so as a result, I think data teams are suffering. And so when I really started to get into the data and analytics industry almost 15 years ago, I took over a team that was shipping analytics to some people in marketing. I remember it was, and I had and he actually broke his data provider was his ETL process. That was wrong. The third successful. It's actually true for a lot of between the and data package from Amazon tomorrow, and then your operations team who just want something they want that runs perfectly, given the complexity. And in a lot of ways, people who are sort of beaten. And sort of team just don't want to break anything. Talking about, and you can find a way to always going to give you crap. Data production is always, and ideas here are being sort of a passive. That's when I about it, and I think that's really good. So and if you're in the data and analytics industry, there's just lots of roles, and some with the data itself, and they're called data engineers or ETL engineers. Sometimes they're called data, actually deal with applying. Sometimes they're called a data. People help. Sometimes people who do statistics, algorithms. There's a if you look at these, simple example here. Let's say there's a data engineering team and a data science team and a self-service team and a data governance team. And the first thing to notice is that there's just a lot of tools out there, and everyone loves their tools. And I don't particularly get into a data science versus Python discussion of, click or this is better. Do you like my fee enterprise is to standardize on tools, and there are reasons for people to love their tools and to want to work in their own way. But there are, it's $100 billion software, and there's just like 50 tools for people to do. And so I guess I take that as an assumption. That's the way the world is. And so there's no sort of one tool to rule them all, to talk about. As a result, people need to work with, say, a data engineer sources data and creates a database table with a name and some sales data. And then the data science team, once loaded, well, they can on top of it, and they use the model, and then they execute the data to create, let's say, and they add a column batch case, and there's different ways to do it, but the data science team. Stations have a self-service team, and what I mean by that is people who are embedded in the business, and the business teams understand. They need to visualize data. Whole industry that's popped up. In the sort of, but these teams age of data analytics. We put it in a database. We create what I think is a factory of insights. And you're going to hear what happens as data stations, and finally give to the customer before about it as a factory. A helpful way for you to claim control of this 1970s era process that we. And then the are always asking for to pick up a piece of station on that factory, change something in it, and then put it back in production quickly. We've got this the innovation pipeline idea developed into production to do both these things. Low error falls of our data, and these things are, and that actually contributors, but managers. Break things. Or late, and then in a central running a factory. We talked about these service, and they may all actually work for the same person, a chief data officer. Have done this where the soup to nuts. From data, and I try to But the back end, there's a self
Okay, Chris,
everyone a single throat. The idea of dev, individual contributor, that's you sort of have a develop work to them. There's a many to many organizations. There's sometimes it's the IT team, and they own perhaps an enterprise data warehouse, perhaps a marketing data warehouse, a data enablement platform, and they have data engineers and perhaps data scientists, sometimes not, but they're trying to have this, they have this centralized, perhaps enterprise-wide or multi-domain view of the world. And then organizations have found that they could get a lot of velocity on top of that when they hire data analysts to use tools like Alteryx and the whole set of visualization tools, data prep and data analysis tools, and they're not in the same location. But if you look at it, the person who receives the value, in this case, the VP of marketing, receives the sum of value of both those. And so the data engineer's got to do something, build a database, the person doing the data visualization who's in a different location. And so you have this coordination problem between the centralization of work and the decentralization of work. And this, if this metaphor applies in a lot of cases, right? We've got a federal government, but we've also got states' rights. In sales, you've always got this idea of, is a salesperson an entrepreneur or an automaton? And the centralization or freedom tension happens in a lot of organizations, and it's happening again here in data and analytics. And it creates challenges, right? So for instance, if I'm on that home office team and I've built a bunch of schema and I want to change the meaning of a column, how do I do that without breaking all the reports that sit on top of that column? Because there could be thousands of reports and I don't have any visibility into it, and I don't know if something changes. Likewise, if I'm in one of those lines of business and I want to add in a new data set, how do I make that data set available to everyone else? How do I govern it? A lot of organizations, VPs of marketing says, I've got 4 definitions of market basket. And sometimes that could come from the data, or sometimes that could actually come from the calculations or configurations on top of that data. And so if you've got lots of organizations who use a reporting tool, sometimes the way that those reports are shared among the analysts is by what's called copy and paste engineering. Or I built my Tableau workbook, I have a calculation and I mailed it to someone else, she mailed it to someone else, and so on. And pretty soon that calculation that I made one morning is now in 15 different reports. And how do you, if I find a problem in it, how do I know which one of those 15 reports it's in? And so you get these inconsistencies. And then finally, you just, if you want to do some new work, integrate some new data and do a new visualization, you've got a coordination problem here. And what we're going to talk about is a way to coordinate people that doesn't require, lots of meetings and lots of talk. And another way to look at this coordination problem is, and this is a bit of a complex chart, is to think about it in an abstract way. And if you follow this diagram from left to right, if you look at the left-hand side, think of it, the D is a development team, and there's the sort of branches off these are each one of the people, and maybe there's a data engineer and a data scientist and someone doing BI, and they're developing things. But if in the second column, they've got, once they develop something, a model, a new data set, a new schema, they've got to push it to production. And sometimes organizations have a very defined way of doing that, dev, QA to prod, in the centralized, maybe more IT controlled way. But often organizations We'll have a decentralized team. So we'll have a bunch of people using, Tableau, a bunch of people using Alteryx around the organization, and they're developing different things. And, they've gained a lot of flexibility being able to do that. And also those organizations are also then pushing to production because you can go into Tableau and publish a Tableau online right away. And so you end up with this almost like if you look at the right, this network of different development teams around the organization and different ways and paths to production. And so you've got this sort of almost a cornucopia of collaboration complexity that exists today. And so there's an argument that says you should centralize everything, and that line of business analytics and spreadsheet data marts are something that need to be stamped out. I don't particularly share that view. I think that it's the cat's out of the bag and it's happening anyway, and these self-service tools are sort of here to stay. And so, but I do think giving errors to your customers is bad, and I do think that being able to change things really slowly is not a good thing. And so how do you gain some semblance of control of this situation? And so let's talk a little bit about this. So why does this situation exist? So there's this Melvin Conway. It's a long, he obviously looks like a guy who existed in the 50s. And he says any organization that designs a system, a technical thing, will inevitably, in the architecture of that system, will reflect how that company or that system or that team is organized. So I believe that DataOps, or data analytics in general, follows Conway's law. So how teams are organized to do data science or data engineering or data analytics and visualization or production is kind of reflected in their pipelines. And what I mean by a pipeline here is not just data. I mean anything that happens on top of data, a model, a visualization. And so this is actually, in some ways, when I was a software engineer, you would say this to your fellow software engineer buddy and say, "Oh, this is designed according to Conway's law," as not a good thing. Because I think technical systems naturally have their own organizational structure. And just because some execs in a room decided to break up the team this way doesn't mean the thing that you build, your software, your car, your data and analytics should reflect that. And so if we think about it, that you've got a typical organization, we've got a data engineering team and maybe a data science team and then a production team. Well, they're all working on their own pipelines. And the data engineering team is doing more data work, the data science team is doing more model work, but sometimes they overlap. And then they're all in some sense pushing to the production team who's got to run it day in and day out. And so these, if you think about the productions, the development pipelines, the in-production pipelines, that team structure is really reflected in it. And so also, if you look at how people work in development, where you've got a bunch of data engineering teams working on a development task, and maybe Tom and Sue and AJ here are working on one development task, and then there's another development task who AJ and Ann are working on, they're rolling up into maybe a QA environment or a UAT environment and finally getting to prod. Likewise, the data science team has got their own way of sort of breaking up tasks and then putting them together. And so it's further complicated that there's sort of these pipelines all over the place. And this is normal. It's not a bad thing. It's just a sort of a reflection of a perspective on how we work today. And even if you think about it from a self-service perspective, where you've got taking that diagram I showed before and saying there's a data engineering team and a data science team, and then you've got a self-service team where they're pushing to prod, you just end up with this sort of just complexity of pipelines all over the place. And at the end of the day, our customers are kind of seeing a path through these pipelines, right? They're seeing something that comes from building the database, applying the model, and doing the visualization. And it's hard then to it's understandable then why you would get so many errors, because it's really hard to see where the error comes from because it's all has different teams. Likewise, you can also see in this diagram why it's hard for an individual to understand where the errors came from. If I'm doing my data science work here and I'm looking only at my world, I don't see that I've broken anything to the right of me or to the left of me. And these couplings between organizations and between systems, they don't exist anywhere in a technical sense in our organizations. And so the idea of DataOps is that a common platform can kind of overcome Conway's law. If we can get people to collaborate across these pipelines, with security and permissions and kind of shared pipeline constructs in technical environments, then we can start to sort of break the chains of Conway's Law by giving them a common platform to do it. So I'm going to keep going here, and we're going to ask questions at the end. So how does the idea of DataOps fix this problem? And so, first of all, the term DataOps it's been around for a few years. Actually, there's a company in Arizona who owns the term DataOps.com, and it's two women who've been working in data since, I don't know, the 80s or 90s. So the term's been out there. But it started in just the past 3 or 4 years. It started to gain traction, and I think Gartner put it on its hype cycle starting in July of 2019. If you actually look at Google Trends over the past 2 years as a proxy of market growth, and you can kind of see, if you look at the sort of 12-week moving average, there's sort of a 500% growth in search volume over time, which is great. But if you actually so that's one indication that it's good. There's a lot more media articles, a lot of companies branding themselves at DataOps. My company got to have a cool vendor. There's just a lot more buzz around the term DataOps. And as a result, there's also just a lot more confusion about what it is and why you should do it. And like most tech terms, they sort of inflate and big data became everything in data and analytics. And unfortunately, I think due to DataOps' popularity, it probably will get to that point. However, we've strove to kind of have a very clear definition of why do DataOps and what DataOps is. And so that's what we're going to talk about really here. What is DataOps? And so I think if you look at mostly all definitions of DataOps, say it's sort of like doing what those DevOpsy people do in software, those agile DevOpsy people do, and apply it to data science and analytics, like in general. And one of the interesting things, having bridged both worlds, is that a lot of people who spend their career building software, and I spoke at the DevOps Enterprise Summit about DataOps this last year, don't know that much about data science or data engineering. I mean, they sort of know the words and principles, but they don't really know or think about it. It's sort of that other group in another room. And then likewise, there's all of us who do data and analytics day in and day out, we sort of have a glancing idea of DevOps and what software people do. It's as if we graduated from college and took one door left and one door right. And you either took the software door or an IT door, or you took the data door. And we all have the same set of talents. But what's happened in the software industry, and starting kind of around 2009, 2010, is this idea that you need a technical platform to be agile, that there's a set of ways to help you release your software in an automated way with fast time. And so what that means is that teams now, and in the 90s, I was a software development manager. I was a director of engineering. I could ship software every 3 months, and that was actually pretty good in 1999. Now, if I were to go get a job 20 years later saying I could ship software every 3 months, no one would hire me, because the expectation is I should be able to do it in 3 days or 3 hours or 3 seconds. And so the entire industry's perspective of how fast you should get software out the door has changed. And that idea is really bounded in the same set of ideas that drive DataOps, is that cycle time, getting ideas into customers' hands, automating it, and handling the complexity of systems and coordination through technology produces a better outcome. And in almost every way, people can release faster, the quality of software goes up, and the teams are spending more time focused on what matters. And then if you actually look at lean and the idea of building cars, lean manufacturing or the Toyota production system, it does improve efficiency, reduces waste, increases productivity, and makes cars that are better. And so, there's some books, a guy, W. Edwards Deming, and The Machine That Changed the World, that I think are really interesting in this regard, and also the ideas of statistical process control. And so if you take these ideas together, Agile, which is a way of organizing software teams, that was, the Agile Manifesto was written in 2001, and then DevOps, which is sort of a technical way to do software development. And then lean manufacturing, you apply those ideas or principles to the more complicated world of data and analytics, you get DataOps. So if we think of it from a definitional standpoint, so data ops is a set of technical practices and cultural norms and architecture patterns that enable really four things: cycle time, fast cycle times, low error rates, high collaboration, and measurement. And so what does cycle time mean? It means the ability to rapidly experiment and innovate. So you can get your hands on a keyboard and create a model and deploy it, change a database and deploy it, change something in your data and analytics value chain and get it in the hands of your customer to get feedback quicker. And what that really means is that you're maximizing the amount of learning your team has, because cycle time and feedback forces your teams to learn. But you've got to be able to do that in a way that has low errors. And in this discussion, I use errors in a very broad sense. I don't mean just data quality, because if you have poor data quality, that could result in an error. But you could also have perfect data quality, and you could have an error, meaning something happened in your processing, or you were just late. And then we've already talked about the idea of collaboration across this sort of complex set of the tools that people have, who they work for, the environments that they work in. And then finally, how do you measure? And one of the things that I think the success in DevOps and the success in manufacturing is they see the systems they work on as a source of data. And then they can use that systems that their teams work on and understand the data that system throws off, and then be able to analyze it for improvement. And so the systems that we work on are these pipelines. And I think they actually produce a whole bunch of interesting data that can help us improve as teams. So why do companies implement DataOps? And so if we forget the right-hand column and look at the left-hand column, they come at it in different ways. So like you, they start off hearing this term DataOps and start wondering what the heck it is. They do some reading, and then they say, well, what? They'll put their business hat on and say, well, what can I do? What difference does it make? Sounds cool. Well, the first part is they're going to try to focus, one company's focus on errors. They're getting yelled at by their business customer because the data's wrong or something broke or they're late, and they feel beaten up because their VPs are calling them up. And I had this very similar experience in my life of having VPs call me up and yell at me because the data's late, and I'm an introvert and I don't particularly like to be yelled at. And so, one way to a lot of organizations have taken that fear of errors and instantiated it in this sort of Word document, meetings, handoff, technical review board processes. And that is a way to review to lower errors. It has the result of slowing down deployment of new things. So instead of being able to change your data warehouse every week, you start to have data warehouse changes and new data sets come every 3 months or 6 months. And so that's another way that people come at data ops is we just want to change things faster in our warehouse, our models aren't getting into production, or our warehouse takes 4 months to deploy 20 lines of SQL. Other organizations come at it from this sort of centralization versus freedom. They have a lot of self-service teams out there, and perhaps the IT team is worried that they're going to do stuff that's out of compliance. Or there's poor collaboration between their development teams and their analytic production teams. And finally, I think some leaders want to be more data driven about the work that their teams do, and can you measure that? And so these sort of business effects around lowering error rates, increasing the deployment velocity and cycle time, about resolving these collaboration and coordination problems, and just management measurement are ways that people come at doing data ops. And you notice what's not here. There's nothing about buy a new database, buy a new ETL tool, use the latest, do this type of predictive model versus that type of predictive model. This is actually nothing to do with databases or models or visualization tools. You can implement data ops on a 15-year-old SQL server. You can implement data ops on the latest and greatest cloud-based streaming event-driven architecture. It's really invariant. This is about a process in which you develop analytics, and the substrate, the substance that you develop analytics on, is up to you. And there's reasons, and I'm a technologist. I love the what kind of model you have, or what kind of database, or how you viz. All those things are really cool, but it's not about that. And fundamentally, I think you as a leader, you own the stuff you own the process in which your team works. and the technology itself is just, will change. So how do you do data ops? And so if we think about this, we have another presentation where we break it down into 7 steps plus 3. And we've hinted at some of them here. So the first step is what we call orchestrate 2 journeys. And in there, it's about running a good factory, being able to deploy. The second step is about adding tests and monitoring. And so what enables all this stuff to work? How can you, a good data ops team should be able to take someone who just graduated from college, have them be able to change, tweak a model, tweak an ETL process, and deploy it to production within their first week and not have any problems. And that's done because you've built a system of tests that happen in development, regression, functional performance tests, as well as monitors that are in production that tell you if something goes wrong. And we are a big believer in automated testing and being able to have that as a way to allow you to actually do data ops. And there's a whole set of how do you test data? How do you test the code that acts on the data? How do you test your pipelines? What's a good test? What's a bad test? What are types? And we've got a whole series of discussions and blog posts about that. And then the other idea is that in data ops, we're actually much more interested in the code that you write. It's actually about, I think data ops is more interested in the Tableau workbook itself, the SQL code itself, the Python model, the Informatica job, all that stuff. And all that work that you're doing should be put in a version control system. It should be put in one place. And then you should be able to branch and merge it because it's about the process that acts on data. And so, and that process itself is code, and that's very much in the software engineer sense of code. And then we talk a little bit about using multiple environments, how to abstract dev and production, how to parameterize your processing and reuse. And then we're going to talk a little bit about here in the next one about sort of architecture and metrics and some comparison to sort of DevOps and DataOps and other ones, just to whet your appetite. So the first one is being a technical guy, I've seen so many different data architectures, and over time there's been different data architecture patterns, right? For a while it was put everything in Hadoop, or then Hadoop next to another database, and now there's sort of the S3 Redshift Snowflake pattern, and there was sort of Kimball's data warehouse, and then there's different ETL tools, but they all sort of have this, whether you're talking about a 1995 architecture, or 2015 architecture, or 2020, they all have the same sort of patterns of, I get some data in somewhere, I do some processing on it, I get some refined data, I do some data science, some visualization, some governance. And data architectures are very focused on what happens in production. They're designing the production system, but it doesn't reflect the operations, the ability to change, and that collaboration angle. And so we think that in data ops, think of it as a right to repair. You should think of as a first order item that you should be able to change your architecture and be able to focus on automatic deployment from dev and test to production, environment creation and management, orchestration and monitoring of testing and production. That all these features here are first order things that you should think about when you're designing your data architecture. And if you stick to just a production only architecture, you're missing half the picture. And we're not the only one who agrees. Gartner just came out in their 2020 planning guide for data management, a very similar idea about being able to think through how you deploy from QA to dev to prod, and be able to think about your data architecture with that. And so the second idea here is more of my experience as a manager. And there's the old managerial adage of you can't improve what you can't measure. And so I think there are things that we need to measure, and analytic teams, I think, are not very analytic about measuring what the work that their team does. We're trying to get our customers to be data-driven, but we're not sort of data-driven about the day-to-day work of our teams. And I think the things that we need to measure are how productive are your team as a team or individuals? What is the error rates in production? Are we late? What are your data providers doing? Which data provider is giving you erroneous data sets and how often? Am I meeting my SLAs? How fast can I deploy from dev to prod? How many release environments do I have? What's my coverage in terms of testing? And I think these sort of metrics can be derived from tools like my company's or other tools. But if you can start to measure things, you can start to make it visible, and then you can start to help people improve. And one simple thing I did in 2006 at this job I talked about was I made a spreadsheet, and then I wrote down every error we had every week. And then every 3 weeks, I'd sit with people and have a quality circle, and we'd look at every error we had in that past 3 weeks. And then over time, we just started to look at that report of here's all our errors. And then we started to see patterns. This error has happened, every 4 weeks for the last 3 months. And it doesn't have to be nice charts and graphs. Just being able to put this in a place and reflect and look on it with your team, and then be able to make changes based on that. So you can start simple and move forward. And then there's a lot of question of like, what is this ops stuff? I hear about DevOps and DataOps and model ops and AI ops and DevSecOps, and there's all these words. And actually, I think it's interesting because there are differences between DevOps and DataOps. And actually, the most popular blog article that's got over 40,000 views that they wrote is a comparison between DevOps and DataOps. So I think they are different. But I have a little bit more subtle view in that if we look at DevOps and DataOps, and in fact, all these ops words that you hear, they're all based in, at the highest level, a kind of similar business management concept and approach to, I've got these people who are working on this technically complicated thing. It's an assembly line, it's software, it's a data and analytic process. And whether you call it a learning organization or the Deming principles, there's lean, there's a bunch of ideas in business management there, but they're all based on, I've got a bunch of people working on a technically complicated thing. And in particular, there's ways that teams can manage themselves. There's Agile or Kanban or Scrum. There's Safe Agile. There's the Spotify method. There's ways that you can organize your teams. And likewise, there's in manufacturing, there's sort of Six Sigma and total quality management. There's certifications here. There's experts. And these are all really good ways. But if you kind of break it down into the organization that applies to, I think more Six Sigma and total quality management applies to industrial manufacturing teams. You can apply Agile or Kanban or Scrum to software teams. And then the technical environment that those teams work in that enables them to be agile has these words. Sometimes it's called DevOps or DevSecOps. It also has the term AI ops, which is applying algorithms to the streams of monitoring data. There's GitOps, which is making your environment, your technical environment centered in Git. And I think the similar idea here is instead of taking these business management concepts applied with an organizational management, whether you do Agile or Kanban or Scrum or SAFe, whatever, and you apply that to data science, engineering, or analytics team, you end up with DataOps. And I think, the idea of model ops or ML ops certainly applies because it's really doing what I think of data ops for data science teams. There's other people who've written about governance ops, data governance ops. You could call data engineering ops. But for brevity, I just end up calling it data ops. So in general, they're all, whatever term it is, they're all based in the same idea that this is how you manage your teams. And so I hope that clears it up for you. So the last part, what does my company do, and what does Data Kitchen help? So we've been at this for about 6 or 7 years. My co-founders and I really started the company because we suffered that emotional problem that we had at the beginning. We were getting beat up by data providers who didn't care about us, by customers who said we were too slow, and production problems left and right. And we just, at the end, we just didn't believe there was a new magic tool that would save it for us. And we tried. We actually tried to build in a previous company. We tried to build one. And so what we've done is build a software product that does that solves these problems. It does these 7 steps and these 3 steps, and we use a lot of food metaphors and kitchens and recipes and tests and ingredients, and we'd love to talk to you about it. Because we think it's pretty cool. But more so, the purpose of our company is in 2 ways. Well, we want to make money by selling software, but also we want to promote these ideas. And we think that these ideas can be instantiated in our software, but you don't have to use our software to do it. And so we're one of the reasons that we spend time in improving these discussions and writing a book and talking about it is I think these ideas are important and really need to go throughout the data and analytic industry. And so finally, what does our software do? And we talked about the percentage of time people spend each week. And if you think about what happened, if you all remember the Iowa caucus and the data problem with the Iowa caucus, they had a system that recorded the votes. The recording of the votes was right, but then they were extracting the data from the system that recorded the votes to analyze it. They had a big ETL problem. And I just, when that happened, it sort of the hair stood on the back of my neck, and I really felt sorry for the team, because I've had problems where, my ETL process broke, and I've had a VP yell at me. I've never had a problem where the entire country was yelling at me because I had a data error. And so, the idea is using our software and applying DataOps principles, you can reduce the amount of errors. You can reduce the IO caucus problems down. And then that gives you more room to actually develop more features. And it actually gives you more room to focus on process improvements, or a term from software engineering, improving your technical debt or fixing things that you've already done. And likewise, what we've seen is that the deployment latency, how fast you can get something from dev to prod, instead of going from weeks to months, goes to hours or minutes. Your production errors goes down. And I think your team actually ends up being sort of happier and more productive. And so the last idea I want to share before is this perspective that DataOps is something else. And this something else idea is really about the people and process. And by focusing on the people and the process and the operations, you gain a benefit. And so, like, if you look at Tesla and Elon Musk, he talks a lot about the machine that makes the machine. And I think that's true. We focus a lot on the model and the transformation, but we don't focus on the system that builds that. And I think that's an important perspective. Or if you look at Satya Nadella, who's the CEO of Microsoft, who's done a great job turning around the company, he has a quote that says, if an engineer who's working on software has to choose between working on a feature or working on development productivity, he should choose productivity. He also has another quote that says he wants the smartest people in the organization not to work on features, but to work on the environment to build features faster. And if you look at the software engineering, in '99, I had a release engineer who worked for me, and he actually made less than all the other cool software engineers who were writing Java. Now, that role is called a DevOps engineer, and they're actually paid more than software engineers, because having someone who's a team of people focused on the productivity, the deployment efficiency of your software teams is so valuable that their starting salaries are higher. And in fact, if you look at Google, they have over 2,000 engineers who focus on engineering productivity. So this, as a leader, saying we really need to invest in operations, it's not going to help us tomorrow, but it's going to help us build tomorrow much better. And so that ends my discussion. We've got about 12 minutes left, and I'm going to turn it over to Beth, and she has been hopefully grabbing all the questions and putting them there.
Yes, thanks very much, Chris. That was a great overview. And I encourage anyone who has a question to please enter it in the question box, and we'll try to get through as many as we can. So I have a few that came in. Here's the first one, Chris, is what is the best first step if you've decided to subscribe to DataOps principles?
Well, that's a really good question. And so I think what we try to do is not think of DataOps as this all-encompassing thing. We think it's try to find a first step. And a first step is to say find a problem to solve. And it could be that problem on you're having too many errors in production. Well, just focus on that. The second is, well, it just takes me forever to deploy from dev to prod. Just focus on that. And if you can find a project or a team that's willing to focus on those one thing and improve it. So don't boil the ocean. Find one part of the value with one team and then improve that, and then go from there. And so, we've actually our last webinar was about that you can record was about sort of 3 or 4 cases of our customers who started with us and what they focused on first and why they did and what kind of results they have. And so DataOps may seem like a big thing, but you can break it down into smaller components and then start working on each. And there's also part of it too, I think, in some organizations is the sharing of ideas and trying to get people sort of bought in that you can sort of reclaim control. You don't have to be sort of paralyzed with fear that someone's going to yell at you when the data's wrong, or running around like a hero on the weekends, fixing things when things break. That there's a better way. And we've written a book on it, we have talks on it, and it's helpful to sort of attack the emotional part of change as well as just finding good projects to do it.
Great, thanks, Chris. Okay, here's a long one for you. Okay, so at times production teams can see what DataOps engineers and data scientists and dev to be constantly creating technical debt, especially when they are delivering iteratively to users to provide value and obtain feedback. How can these two teams complement each other and avoid the conflict or the perception of conflict mentioned above?
Yeah, and I think that is a challenge, right? Because what is DataOps? It's saying work iteratively. That means be able to get something from the hands of your data scientists or data engineers into production quickly. And so some technical things actually are better probably with a long cycle to think about it. And that's true, but it doesn't mean that you have to go back to a waterfall method. And so what I found is that if you can get we have a term in our company, get some value in the bank a little bit of it, and then bank a little bit more, and perhaps take some time in one of your periods not to deliver value, but to refactor or improve what you have. And so it becomes a question of what are you doing that week, and try to allocate with your business customer. I've got some of the stuff I'm doing new things for you. I've got some of the steps I'm trying to do to improve my process. I'm adding more tests. I'm upgrading the server. And then I've got another part where I'm trying to refactor or improve or document what I currently have. And so it's a balance with your customers week in and week out what you're doing. And if you can gain more trust to them by at least delivering some of the things that they want every week, what we found is they will work with you to say, okay, this week I'm going to refactor a bunch of code and improve it, or this week I'm going to add a whole bunch of more tests, or I'm going to document what I previously didn't document. And so seeing it as it's not an all or nothing, it's this period, this week or 2 weeks, we're going to do this. We're going to have maybe this week I'm doing all new features. Maybe next week I'm doing a whole bunch of refactoring. And the balance between how you allocate resources every week and the dialogue you have with your customer is important. And that's all built on trust. And so a lot of organizations end up having distrust between their business customers and their development teams, or distrust between their development teams and their production teams. And so having everyone have a seat at the table, and the production team saying, look, you've given me crappy code the last 3 months. Can you find a way to make sure that you catch all these regressions? Well, maybe a whole bunch of regression testing should go into your sprints for the next few weeks to fix that.
Okay, great. Here's another question. How can DataOps be driven in an organization from a top-down approach?
I think it helps a lot to have senior leadership sort of bought into the idea of DevOps or DataOps or Agile as a way to work. It isn't a necessary requirement, but it makes it a lot easier. And so some organizations have made the change over to DevOps and Agile principles a fundamental part of what their CIO's goals are. And then the data and analytic teams are kind of left saying, well, how do I do this DevOps stuff with data? And then they put Jenkins in and they put a couple of unit tests on their ETL code, and then they're still having a bunch of errors, and they still have the same sort of problems. And I think there's not just doing Agile, and I've been in some data organizations where they have rooms set up for Agile and they have all the posters, but they're still basically doing waterfall. They just do a dev sprint, and then a QA sprint, QA sprint. They do WAGILE or waterfall Agile or Potemkin Agile. There's a bunch of terms. And so I think you do need executive sponsorship. It's helpful, but you also need to sort of think deeply about exactly how you do it. That doesn't say that 2 or 3 people can't start using these principles on a small team right away. I don't ever, I'm a technical person. I don't ever want to deploy a bunch of data code to production without running a whole series of tests on it first. I don't ever want my Saturdays interrupted. I don't ever want to sort of walk off the soccer field again with a bunch of data errors and my wife scowling at me that I have to go in the car over my cell phone to fix it. So I think it's better to start with exec sponsorship, but you don't necessarily have to.
Okay, so we had a couple questions about the best organizational structure for data ops. So one is, what size of IT environment is suitable for applying data ops principles? Say we have a BI team of 5 guys consisting of 1 DBA, 2 ETL developers, and 2 report developers. Is this environment suitable, or should it be bigger?
So it depends on how far you want to go with heroism, right? You can actually, on a smaller team, you can heroically divide, and people who are willing to work smart and work weekends, heroism gets you actually quite a long way. The problem is heroes burn out and heroes quit. And so if you've got that small team and they're comfortable fixing problems on the weekends and comfortable going the extra mile, and you're not afraid that any of them are going to leave, then maybe it's data ops isn't your highest priority. But what I've found is that people who end up doing heroism week in and week out get bored and get frustrated, and then they quit. And then you're left with a hunk of ETL code, a hunk of data code, a hunk of visualization code that nobody has any idea how it works. And then you throw it off to another person, and now they got twice as much crap to deal with, and then they leave. And so partly what you're trying to do at data ops is make it so that people can easily work in a way that they don't create they create something and they know it's going to work, and they know if they hand it off to someone, it's still going to work because it's automated. It has a whole bunch of tests about it. You built a system that can handle the loss of any one individual. So so I guess that's the answer is like small teams, I think should follow data ops principles. In fact, individual data engineers should follow data ops individuals, but it's hard for some people to overcome the bias of heroism, because it's nice when your business customers give you praise, saying, oh, you work the weekends, isn't that awesome? And so it really does take a little bit of leadership to say, and often I've said, you sort of praise people in public for working weekends, but then privately you talk to their manager and say, why is that guy working on weekends? Why have you not set up a system that they don't have to? So that's it.
Okay, great. So we have time for about one more question. I think this one segues nicely from the last. How mature are the customers you work with in their data ops practice? What's the biggest challenge they face in terms of growing in maturity?
I think they start with different levels of understanding of sort of the idea of an iterative process and what it means. And so companies that tend to be bigger and more mature have a lot of sort of Word doc processes and meetings set up to handle collaboration, and trying to unlearn some of that is harder for them. And then the journey that they go on is trying to find a project and trying to start doing an iterative development path, and then seeing that success and then getting more momentum behind it. And so it starts small, show value, communicate that value, and get more people on board. Because I think, I don't think my experience is it's very rare that once people understand these principles, understand how the systems work, that they don't want to work in that way.
Okay, well, great, Chris. Thanks so much. We are at the top of the hour now. So there were a few questions we didn't get to. So if we didn't get to your question, we will just follow up with you directly afterwards and with an answer. And then also just wanted to let everyone know that we'll be sending out a recording and the slides for the webinar shortly afterwards. So be alert looking in your email for that. And then I'd just like to thank Chris for a great overview. That was a fantastic presentation. And thank you all for joining us today.
Yeah, thank you. And just if you can see my screen, we've got sort of 4 webinars scheduled to come up later. And then we also have a lot of ways that you can learn more about data ops. You can actually go read that data ops manifesto I talked about. We've got a whole almost 200-page book that you can download for free that talks about these ideas in long form. Gene Kim, who's sort of famous in software's DevOps world, has an excerpt of his book that you can go. We have a blog, and even the you can see this rotating GIF. We have a bunch of aphorisms that you can see. So we've a lot of resources for you to go and that are free that you can just learn about DataOps. So thank you very much. And just finally, given our environment, I hope everyone stays safe and stays warm and stays sane, and of course stays healthy.